In an earlier video, we worked this problem where we took a polynomial 2x cubed minus 5x plus 8, and we use long division to divide it by x minus 3. And so in this problem, the divisor was x minus 3. The dividend was the numerator, the polynomial we were dividing into, which was 2x cubed minus 5x plus 8. And I'll spare you the algebra. If you want to go back and watch that video, you're welcome to. But the quotient after doing the long division turned out to be 2x squared plus 6x plus 13. And there was a remainder left over of 47. And so that's all well and good that we know all those things, but that still doesn't help us with, like, what do we do? Like, how do we use those things to write an answer? The question still remains, what is 2x cubed minus 5x plus 8 divided by x minus 3? Obviously, it has something to do with all these things, but we're not really sure what. Well, before we give this answer, we're going to come back and answer that. To answer this question, we're actually going to look back just for a moment at a numerical example and try to figure out what goes where in our particular answer. So I'll do this very quickly. If we take 4 and divide it into 71, 4 goes into 71. I'll spare you the algebra. It goes in a total of 17 times. 4 times 17 is 68, which leaves a remainder of 3. So how would we leave this answer? What is 71 divided by 4? Well, mostly it's 17. That's the majority of your answer. You divide 4 into 71, it goes basically 17 times. If there wasn't a remainder, if the remainder was 0, we would be done. But now, how do we account for this remainder? Do we just tack on the extra? Do we just tack on 3 extra? No, because 71 divided by 4 is not 20. So what do we do with this 3? Well, that 3 that's a remainder, here's the key, is a portion of the divisor. So it's 3 out of 4. So you get your meat of the answer being 17 plus the remainder out of the divisor. And so typically for a numbers example, we would just write 17 3/4, but we're going to have to think of it more along these lines when you think of this in polynomial terms. So here's what we learned. If you have a dividend, a large polynomial divided by a divisor, then your answer, the majority of your answer, the meat of your answer is going to be the quotient. And in fact, if there's no remainder, you're done. It's just the quotient. But if there happens to be a remainder, then you're going to put plus the remainder out of the divisor. Okay, which is exactly what we did in this numerical example. We had 17 was the quotient plus 3 out of 4, the remainder out of the divisor. So anyways, this is the model that we use even for polynomials. It's easy to understand for numbers, but we still keep the same model when we're dividing two polynomials. So let's come back here to the very first page again. And we have our divisor and our dividend and our quotient and remainder and all those good things. So when you take 2x cubed minus 5x plus 8 divided by x minus 3, the majority of our answer is the quotient, 2x squared plus 6x plus 13. Now, there is a remainder though. So what do we do with the remainder? We'll put plus 47 out of x minus 3. So it's the quotient plus the remainder over the divisor. And actually this makes pretty good sense, because if you think about these degrees just very, very loosely, if you look at the leading terms here, you have 2x to the third divided by x to the first, a cubic polynomial divided by a linear polynomial, then you would get a quadratic. You would get a degree 2 polynomial. That makes perfectly good sense. So anyways, once you get your divisor and your quotient and your remainder and all those good things, this is how you write your answer after doing long division of two polynomials.